Hey there, this is Jamie and welcome back to what I believe will be our final analysis video for the Zappos scraping project. This unfortunately is the longest one to do, and I've made myself a little cheat so that I can get through it relatively quickly. So I'm going to pop over here into sheet 7 where I have completed the analysis including the directions. So you'll see that I've brought the data over in columns B through H. I've got A hidden, and then I've got 1, 2, 3, 4, 5, 6, 7 scatter plots. Here is my description of what we need to do, and that is my discussion. All right, let's pop back over into our original sheet and I will show you how we got there. So I'm going to label this sheet A5, and that's what you're going to do, and you're going to put your discussion here. Like some of the other things we've been working with, the easiest way to get these scatter plots and have them show up where you want them is to bring over the data that you need. So we're going to bring over all of the data to start. And we're going to place it in our spreadsheet in our tab A5. And I'm going to start by deleting our model and our brand. Why? Because I have information for each of these shoes and I'll never need to know what it corresponds to. Or we could hide it if you prefer. Let's hide it just in case we maybe want it later. All right. The next thing we need to do is when we think about scatter plots, next thing we need to do is need to get these variables in the right order. When you make a scatter plot, Excel defaults, you highlight 2 columns. This is my finished sheet. And when you highlight those 2 columns, like say I want to compare overall rating and price, the column that's on the right-hand side becomes the x-axis and becomes the y-axis, overall rating. And overall rating is the thing that we are interested in. And when we make scatter plots, what Excel does, is each one of these points corresponds to one of these observations, and this one here corresponds to an overall rating where the price is $199.95. As you can see here, over, close to $200 or whatever that was. That one's $249.95, right over there above the price of $250. And the star rating is 1.7. So it's plotted that. There is one dot on this graph for all 224 of our shoes. Then we ask Excel to plot a line of best fit through the data. It's the line that minimizes the space between each dot and the line. It's the line that gets as closest to as many points in this chart as is possible. You can't get a line that fits the data better. And then we ask Excel to tell us the equation of that line. You guys remember y equals mx plus b? Well, in this case, y is overall rating. And it equals mx, where x is the shoe price, plus b, which is the intercept, which meant if the price of a shoe was 0, that line would intercept the y-axis at about a value of 3.9, which we know isn't going to be a meaningful thing. There isn't going to be a shoe price of 0, but that's mathematically where it would input. If you're in a range like this where there aren't shoes, you really have to take it with a grain of salt. Okay. The last piece of information this gives us is the r-squared value, which if you turn this into a percentage from 0.0055 into a percentage, we'd carry that decimal place over 2 spots, and that would be 0.55%. And what that means for us is that variation in shoe price explains about 0.5% of overall rating, right? Otherwise, it's not important. Otherwise, we could say it's not a particularly important variable. And that makes sense when you go back to our correlations, right? Price, we found that to have no relationship. Price is not really related to a shoe's overall rating. There are high-priced shoes that are well-rated and low-priced shoes, and buying a higher-priced shoe or a lower-priced shoe isn't going to increase your odds of getting a shoe that satisfies you more. And we can see that here. The line that fits through this data is practically straight. Shoes aren't higher rated here at low prices, nor are they higher rated here at high prices. So getting back to why overall rating has to be on the y-axis, it's because it's the thing that we're really interested in. It's our y, right? Our overall rating is going to be equal to mx plus b. So it's we would call this kind of our outcome variable. If we were trying to predict an overall rating of a shoe based on other things we know, like its price, whether it's on sale, the proportion of people think it's true to size, true to width, or how it related for comfort or style, we could use a much more complicated model, but try to predict it, right? It could be the outcome. So let's walk through how we make this chart, how we make these charts, and how we interpret them. I'm only going to make a couple in my video demonstrating, but you are going to make all 7. All right. The first thing we need to do is get our output variable, our y variable, over here on the right. If we're trying to kind of predict overall rating or understand what explains overall rating, we want overall rating on the y-axis in every one of those plots. So I'm just going to highlight it, grab it when that turns into a hand, drag it over here, and then I'm going to delete column I. I'm going to make my life a little bit easier on myself by wrapping this text, making this slightly taller, and then making these narrower and all the same size. That should make it a little bit easier to read and navigate. Okay, so the instructions say, create scatter plots showing the relationship between overall rating and each of the other variables: price, on sale, number of reviews, true to style, true to width, comfort rating, and style rating. So we're not going to do MSRP here. We can hide it. So the only things I can see are the ones I'm going to be working with. And so make sure that overall rating is on the y-axis. And we do that, we ensure it's there by putting it on the right. And the other variable is on the x-axis. And then we're going to do kind of some formatting and some explaining, but let's just start with the chart. So if we're going to go overall rating and price, I like to do this the same way I did when we were making the box plots. I like to click on price, Command Shift down arrow, hold on to my command, click my lowest rating, hit my Shift and my up arrow, and then over to insert, and then a scatter plot. Well, it's not a particularly beautiful graph when it first comes out. We're going to format it using a series of specific and exacting steps, and I want you to get every single one. We're going to change the title, and the title is going to be, you're going to do this in every one of these plots. You're going to use the same title: price versus overall rating. Only use the phrase versus when you're doing a scatter plot. That's because you've got one variable on one axis, the other variable on the other axis, and every point corresponds to one value of price and one value of overall rating. Then we're going to remove the vertical lines and the horizontal lines. So now we just have our dots. We're going to add our chart element of titles, both primary horizontal and primary vertical. This is going to be overall rating. I'm entering that in sentence case, and this is going to be price. Then I want these ratings and these dollars to have no decimal places on the graph. So I'm going to left click on the graph, right click, select format axis. When this pops up, I'm going to scroll down for number. You might have to jump around here or even Google to figure out where number is on your particular version of Excel. And I want 0 decimal places, 0. Then if I just click on my next axis, I don't have to re-find where I can adjust the numbers. I can just update it right away there. There is my price versus overall rating. And then we can highlight over any of these spots and see this is a price where I've got a shoe priced at $179.99, and overall it's rated 2.4. And we can see up top that we have high rated shoes at all price points. And we have fairly low rated shoes at all price points too. So how do I find out like the gem of the information in here? Like, what's the story? We can eyeball it a little bit, but I want some specifics. In particular, I want to know what proportion of a shoe's overall rating can be explained by its price. And I want to know what happens if price goes up or down. What is that likely to do to a shoe's overall rating? And both of those pieces of information can be found in the trend line. That line that Excel inserts that is as close as possible to all of the dots on this chart. So to get the trend line to pop up, you hover over and click on any one dot. And they wake up. They don't all wake up. You can see that they're just kind of awake. And then I right click and I select Add Trend Line. This interactive box will pop up to the right, and you might have to scroll to see all of these options. We want a linear line. We're not interested in the other trend line options. And the things we do want is we want Excel to display the equation, that y equals mx plus b, and we want it to display the r² value. So here, interestingly, compared to my other chart, it only rounded to 3 decimals, whereas before I was getting 4 on the next tab. Go figure. But what this tells us, I look at the r². Well, when I look at this, I see a couple of things. I see that first, the line that passes through that data is virtually flat. What that tells us is that price changing, moving from $50 to $250, doesn't result in very much of a change in overall rating. Right? You're eyeballing it and you're thinking, well, maybe it goes up a little bit. And you're right, it does go up a little bit. The amount it goes up is 0.0011 ratings for each additional dollar you pay for a shoe. So for instance, if you were to pay, I'm going to enter a formula here and then I'm going to delete it, but if we were going to pay $100 more for a shoe, we could expect the price of the shoe to go up $100 times that 0.0011 times 0.0011. So our overall rating would go up by 0.11. It's not a particularly strong relationship. And that fact that it's not a particularly strong relationship is underscored by this r². The r² of 0.005 suggests that less than 1/2% of the variation in variation in overall rating can be explained by price. So that r², you kind of have to mental math it. You got to move the decimal 2 steps to the right, and that gives you a percent. So it's just that conversion from a decimal to a percent. Like if we were to just type it 0.005 here, right, that's that same number. It unfortunately rounded, but let's just say, that's what it looks like. We'd plop that into percent, right? 0.5% is what that is. So price explains less than 0.5% of a shoe's overall rating, right? So I would say shoe price is not a strong predictor of a shoe's overall rating. It only explains less than 1%. So I would put that in like a not too important. Knowing the price of a shoe is not too important for determining its overall ratings, at least for men's road running shoes that we are looking at right now. I can't underscore that enough. We've got men's road running shoes. We don't have high heels. We don't have, fancy flats. We don't have hiking boots or any other type of shoe. We don't even have women's road running shoes. We don't even have men's trail running shoes. We've got men's road running shoes. And it turns out that for men road running shoes, there's a highly rated shoe at every price point. All right, let's do the second one. Again, we want overall rating on the y-axis, but let's take this on sale variable that's a dummy variable, which means it's 1 if that shoe was on sale and 0 if that shoe was not on sale. This one's interesting because it's going to give us a really different looking graph. I'm going to grab on sale, continue to hold down Command, click on our bottom rating for overall rating, scroll up. I'm going to click Insert. I'm going to get my scatter plot. I'm going to bring it down here and run it through the same formatting experience that we did before with one small change. So this is right. All the values are either 0 or 1, so if you're beginning to panic or if you don't have that, you want to redo it, but that's how it's supposed to look. And I'm going to do the same thing here. This is on sale versus overall rating. Let's remove the horizontal grid lines, the vertical grid lines. Let's add our axis titles. Here we've got overall rating, sentence case. Here we've got on sale, also sentence case. Then on our vertical axis, I'm going to format that axis again, scrounge around till I can find number, reduce it to 0 decimal places. And then for on sale, I'm going to click on this. See how it gives me 0, 0, 0, and 1, 1, 1? I really only want 0 and 1. So my axis options, my bounds, I want my minimum to be 0 and I want my maximum to be 1. And then units, I only want 1. I want a 0 or 1. It's a funny looking graph, but if we eyeball this, does it really look like there's much of a difference in rating between shoes that are on sale and shoes that aren't? Not particularly, right? There are 5-star shoes that are not on sale and 5-star shoes that are on sale. There are, our lowest rated shoe here is on sale with a rating of 1 versus 1.7 for shoes that are full price. Left click and then right click to add my trend line. Display my equation and my R squared and drag it somewhere out of the way. And then take a look at what we got. Well, that slope is slightly negative and the R squared is very small. So again, we've got a variable, whether or not a shoe is on sale, that explains less than 1% in the variation of rating. Shoes that are on sale or are not on sale have very little difference between the prices, and it doesn't explain much. Knowing whether or not a shoe's on sale isn't going to do much for us to know whether or not that shoe's highly rated. And this matches very much here what we saw, a small negative weak relationship, that shoes that were on sale were negatively related with a very weak relationship with overall rating. And that's the same thing we see here. It's a very weak relationship. It explains less than 1%. And then if we look at the equation for the line, this would say that our overall rating is equal to negative 0.1326 times x, where x is the variable for on sale, 0 if it's not on sale, 1 if it is. And because of that, this tells us that shoes that are on sale tend to be lower rated by 0.1326 stars. A very, very small difference, but look how much of this variation there is, right? It really doesn't give us much, and it explains only 1% of that variation. It is not very important. So in this analysis and discussion section, right, you're going to use the R squared to kind of group the variables into categories, not too important, a little important, or very important, right? And it says see the video, and you're seeing the video now. So what's not too important? You know, not too important is going to be something with a low R squared. Is there a hard and fast rule for this in the rest of the world? No. In some fields, you need an R squared of 0.7, like 70 or 80% of the variable of y has to be explained by x for it to be called important. And in this case, you know, that's not the truth. If you're trying to figure out how to improve your shoe, it might be that a 3 or 4% R squared, and R squared we can explain just a little bit of it, might be considered, a little important. So let's draw the line here. We're going to call it not too important if it's less than 1 or 2%. A little important if it's somewhere between, less than 1 or 2%. Something like that. A little important if it's like somewhere between 2% and 20%. And very important maybe if it's more than 20%. Greater than, equal to, greater than 20%, right? These are really rough guides because there's not really a hard and fast rule, and we won't really know if something is statistically significant until we get to a later piece, but this is as far as we're getting in this video. So we're going to leave it with this kind of general feeling about what's important, and we'll test out these results for statistical significance later. So 2 not really important, price and on sale, and that matches exactly what we see here in overall rating. But we add to this piece of correlation by being able to say specifically what percentage of overall rating can be explained by changes in price, not very much. And we can say that if price increases by 1 unit, what would we expect to happen to overall rating? We would expect it to go up by $1.0011 for each increase in price. Same thing with on sale. Less than 1% still, so not a strong predictor, just like we saw with correlation. But if we do put a shoe on sale, we would expect, if we put a shoe on sale, it's not really an experiment, but we would say that if a shoe is on sale, we might expect it to have a slightly lower rating. So let's take a look at something where we would expect to see a stronger relationship. Where we might expect to see a stronger relationship, I think maybe true to size, our style rating, our comfort rating. Remember that you're going to make plots for all of these things. But I just want to make one more with you. And let's address comfort because it has the highest correlation coefficient with overall rating. Of all the variables that are correlated with overall rating, they all have some sort of correlation coefficient. Comfort has the highest correlation coefficient. So let's take a look at that as our last graph. So we've got comfort rating and overall rating. So I'm going to Control Shift down arrow comfort rating, hold down Control or Command if you're on a Mac, up arrow and Shift together, and I'm going to insert a scatter plot. I'm going to scroll down here, place it in line. I'm going to go through that same formatting rigmarole. Comfort rating versus overall rating. We're going to add vertical and horizontal axes. This, using sentence case, is overall rating. And this, also using sentence case, is comfort rating. Then I'm going to get rid of the vertical and horizontal grid lines. I'm going to format these axes. Then I'm going to take a quick look at it. Here I can see it looks to me like this is upward sloping, right? Shoes that have higher comfort ratings also tend to rate highly for overall rating. And these shoes down here that are low for overall rating are also relatively low for comfort rating. We don't really see anything with, too low of an overall rating that has a low comfort rating, although we do see a couple of these shoes that are rated 1 for comfort that, the highest one is 3.4 for overall rating. and all the 5s, or the really high ones, have decently high comfort rating. So it looks to me like comfort rating is going to be important at explaining a shoe's overall rating. Let's get the quantitative pieces. Well, at least for men's road running shoes, right? Maybe women are vain and they're going to be style driven, I don't know. But this tells us for men who run on the road and buy road running shoes. Left click on any one of those dots to wake them up. Right click to get this menu, and then to check add trend line. Come over here, display the equation and the R squared, and then move it kind of out of the way so we can talk about it. And here, now we're cooking with gas, right? R squared is 0.4792. That tells us that just under 48% of the variations in overall ratings that we see in these shoes can be explained by their comfort rating, right? What proportion of variation in the Y variable is explained by the X variable? That's what our R squared tells us. It also tells us, well, not the R squared tells us, but this line, Y equals MX plus B, so we can read that as the overall rating is equal to 0.5397 times the comfort rating 0.2 plus 2 and change. So this means that a shoe with a comfort rating of 4 is likely to have an overall rating that is 0.5397 stars higher than a shoe with a comfort rating of 3. So comfort rating is a good overall predictor of overall rating. And if I jump forward to my next sheet, I can show you quickly all of the R squareds as they appear for men's shoes. And we can see that, like in the correlation coefficients, where comfort and style had the two strongest correlations, they also have the highest R squareds. So style explains 24.3% of a shoe's overall rating. Comfort explains 47%. Those are our biggest predictors. And so for those bigger predictors, I want you in your text box to discuss the R square, what percentage predicts, but I also want you to discuss this slope. And the slope tells us what a 1 unit change in X will do to our overall rating. So if style goes up, a shoe that has style of 4, we can expect it to have a higher overall rating by 0.4764 stars than would a shoe that has 3. So I'm not sure if women will be different than men in this regard, and that's something where we're going to take a look to see how the men's shoes and the women's shoes differ. But I hope this gives you enough to get started on making this plot. And by the time you're done with this plot, your full spreadsheet for this project is done, and your job then becomes to create a way that you're going to explain it. I want you to explain first how the brands differ. What are differences between brands? Most expensive, least expensive, most consistent, et cetera, whatever you think is the most important brand differences. And to use that, you would rely on A1, A2, right, these charts, and A3, the box plots that would show us who are the highest, who are the lowest on any individuals, and then who are quite consistent, maybe targeting a wide array of customers versus a specific low price point customer, right? All those things that you can learn from these charts. Then you'll move on to talk about what makes a good running shoe, right? And at least here when it comes to men, it seems to be that comfort is the most important thing, although style is also important. Fit is important, true to style and true to width. I'm a little bit surprised that true to size is a stronger correlation than true to width, because I would think if the size isn't right, you can exchange for another size, but if it's not the right width, you're out of luck. Also, interestingly enough, for men's road running shoes this term, is that price has zero relationship, and we're going to call that virtually no relationship. And whether or not a shoe is on sale has a slight, small negative correlation with its overall reviews, which makes sense to me because I'm very rarely happy with something that I ordered just because it's on sale, and I bet there's a lot of people who ordered it because it was on sale and aren't that stoked with it. And then from the scatter plots, we can really hone in and say, beyond correlation, what percentage of overall rating can be explained by changes in our different X variables. And R squared tells us that. You just have to remember to convert it to a percentage first. The slope here tells us what a 1 unit change in price would do to the overall rating. So a shoe that goes up by $1 is likely to have overall stars that is 0.0011 stars higher, up by $1. For on sale, that 1 unit jump is from being 0 to 1. That's a much bigger jump, right? So it's no surprise that a shoe that's on sale, when there's either a 0 or 1, as opposed to here where it's a scale of 0 to 300, right? That either or jump makes a much larger difference in slope, even though both of these explain almost none of the variation in price. Comfort is bigger. It explains 47.92% of our variation in our overall rating. I'm sorry, I just said variation in price, but you knew what I meant. With that slope of 0.5, that means shoes that are 4 stars have, almost a whole half, or 4 stars for comfort are almost 1/2 star rated higher in overall rating than one that's rated for 3. The same thing as shoe that's rated with 1, rated as 1 for comfort. We'd expect it to be overall rated about a 1/2 star less than a shoe that's got a 2 for comfort rating. All right. I hope you are feeling like you just accomplished something pretty incredible, because now all you've got to do is put together your descriptors. And I look forward to see what you come up with. Let me know if you have any questions.